Hi guys, how's it going? It's Jordan and welcome back to my YouTube channel. Today we're gonna continue reading this article, which is about the Chameleon model, which basically you can upload like an image and ask for question related with that image. You can generate a new one or make like some questions or advice. For example, you can ask if you are interested in art and those stuff, and you want like a similar image uh, as the image that you provided to the model, the model could answer you and provide you new ones. Or yeah, basically you can make everything with that model. This video is a continuation of the latest one, which talk about this same article. So the last time, the last section which we were talking about was fine tuning strategy, and basically was related with data balancing, optimization, and a couple more of stuff related with that, technical knowledge. But to be honest, doesn't matter too much. As I said in the last video, this is more to get used to the vocabulary and the way in which these articles are written. So yeah, that's the key. Eventually, even if you don't get the idea, if you read many articles because you're in the topic or something like that, you will get the idea. So that's the main point. Let's go ahead with this one. Okay, the next section is for human evaluations and safety testing. Chameleon has significant new mixed modal understanding and generation abilities that cannot be measured with existing benchmarks. In this section, we detail how we conduct human evaluations on large multimodal language models, responses to a set of diverse prompts that regular users may ask daily. We first introduce how we collect the prompts and then describe our baseline and evaluation methods, along with the evaluation results analysis. A safety study is also included in this section. Prompts for evaluation. We work with a third-party crowdsourcing vendor to collect a set of diverse and natural prompts from human annotators. Specifically, we ask annotators for to to creatively think about what they want. Sorry. Specifically, we ask annotators to creatively think about what they want a multimodal model to generate for different real life scenarios. For example, for the scenario of imagine you are in a kitchen, annotators may come up with prompts like how to cook pasta or how should I design the layout of my island. Show me some examples. The prompts can be text only or text with some images, and the expected responses should be mixed model containing both text and images. After collecting an in after collecting an initial set of prompts, we ask three random annotators to evaluate whether the prompts are clear and whether they expect the responses to contain images. We use a majority vote to filter on clear prompts and prompts that don't expect mixed model responses. In the end, our linear evaluation set contains 1.04048 prompts, or 1048. I don't know why we have like a comma here. And yeah, well, okay. Um, Basically, that's 441, and that's 42.1% are mixed model, containing both text and images, and the remaining 607, the 57.9% are text only. To better understand tasks user would like a multimodal AI system to fulfill, we manually examine the prompts and classify them into 12 categories. The description of these tasks categories, as well as their example prompts, can be found in Figure 8. Okay, here basically we have like some graphics related with how this model works. It's wow, I like thinking about it. I don't know if it's like a pretty good idea to talk about this kind so high level technical stuff, even when I cannot share the screen totally, because there are like some important graphics here, and you must understand them to have like a better understanding about them. But reading as well, it makes sense. Like you can associate ideas at least about how it works. The graphics is just like more like a helpful visual visual like a visual helper basically. So we the first graphic that we have here says the prompt task fulfillment rates. Well, we have different models: Gemini, GPT-4, Gemini Plus, and other ones. Wins tires. Okay. The prompts and the prompts and classify them into 12 categories. The description of these tasks categories, as well as their example prompts, can be found in figure 8. Baselines and evaluations. We compare Chameleon 34B with OpenAI GPT-4B and Google Gemini Pro by calling their APIs. While these models can take mixed modal prompts as input, their responses are text only. We create additional baselines by we create additional baselines by augmenting GPT-4B and Gemini responses with images to have even stronger baselines. Specifically, we instruct these models to generate image captions by adding the following sentence at the end of each original input. If the question requires an image to be generated, then generate an image caption instead and enclose the caption in a pair of caption tags. Basically like a caption tag, the initial caption tag and the end of the caption tag. We then use OpenAI DALI 3 to generate images conditional on these captions and replace the captions in the original responses with those generated images. We denote the enhanced responses as GPT-4B Plus and Gemini Plus. In this section, working with the same third-party crowdsourcing vendor, we conduct two types of evaluations to measure the model performance: absolute and relative. Absolute evaluation. For absolute evaluations, the output of each model is judged separately by asking three different annotators a set of questions regarding the relevance and quality of the responses. Below, we give detailed results and analysis on the most critical questions: whether the response fulfills the task described in the prompt. On task fulfillment, we ask annotators whether the response on task fulfillment, we ask annotators whether the response fulfills, partially fulfills, or does not fulfill the task described in the prompt. As shown in figure 9a, much more of Chameleon's responses are considered to have completely fulfilled tasks. To have completely fulfilled the tasks, 55.2% for Chameleon versus 37.6% of Gemini Plus. Okay, basically like the percentage of uh, fulfillment, the fulfilled tasks that Chameleon has, it's higher than the one that Gemini Plus can provide, and 44.7% of GPT 4B plus. When judging the original responses of Gemini and GPT-4B, the annotators consider much fewer prompts to be fully fulfilled. Gemini completely fulfills 17.6% of the tasks, and GPT-4B 23.1%. We suspect that because all the prompts expect mixed modal output, the task-only responses from Gemini and GPT-4B might be viewed as only partially completing the tasks by the annotators. The task fulfillment rates in each category and each input modality can be found in Appendix B. The task categories that Chameleon perform well the task categories that Chameleon performs well include brainstorming, comparison, and hypothetical, and the categories Chameleon needs to improve include identification and reasoning. On the other hand, we don't see that the model performance differs a lot when comparing mixed modality and text-only prompts, although Chameleon seems to perform slightly better on text-only prompts, while Gemini Plus and GPT-4b are slightly better on mixed model ones. Figure 2 shows an example of Chameleon's response to a brainstorming prompt. Relative evaluation. 4.2.2 Relative evaluation. For relative evaluations, we directly compare Chameleon with each baseline model by presenting the responses to the same prompt in random order and asking human annotators which response they prefer. The options include the first response, the second response, and about the same. Figure 9b shows the Chameleon's win rates over the baselines. Compared with Gemini Plus, Chameleon's responses are better in 41.5% of the cases, 34.5 are T, and 24% are inferior. Annotators are Annotators also think that Chameleon's responses are slightly more often better than GPT-4b plus, with 35.8% win, 31.6% high, and 32.6% loss. Overall, Chameleon has win responses from Gemini without the augmented images. When compared with the original responses from Gemini without the augmented images, Chameleon's responses are considered better in 53.5% of the cases, 31.2 are teeth, and 15.3% are inferior. Chameleon's responses are also considered better than GPT-4b more frequently, with 46% win, 31.4% T, and 22.6% loss. Chameleon's win rates over Gemini and GPT-4b are 69.1% and 61.7% respectively. Okay, inter-annotator agreement. 4.3 Inter-annotator agreement. Every question in our evaluation is answered by 3 different human annotators, and we take the majority votes as the final answer. To understand the quality of the human annotators and whether the questions we asked are reasonably designed, we examine the level of agreement between different annotators. The levels of agreement on each question in the absolute evaluation are shown in figure 10. Okay, figure 10 basically says that the inter-annotator agreement on the questions in the absolute evaluation, containing images, image quality, image relevance, language quality, objectionable content, relevance, task fulfillment, accuracy, agreement, all to none. Mm, mm. Okay, basically, basically, this measure the amount of good prompts, if you want to say it in that way, the appropriate prompts, the appropriate responses that the evaluators got after prepare the model basically. For questions about simple objective properties of the responses. Okay, for questions about simple objective properties of the responses, we very rarely see 3 annotators disagree with each other. For example, annotators have unanimous judgments on whether the model responses contain objectionable content, hate speech. Okay, for example, annotators have anonymous judgments on whether the model responses contain objectionable content, for example, hate speech. In this case, all models produce safe responses. For some questions, such as whether the response fulfills the tasks or whether the model interprets the prompt correctly, when one annotator's judgment differs from the other two, the decision is usually still close. Fulfills versus partially fulfills, rather than opposite, fulfills versus does not fulfill. The inter-annotators agreement on relative evaluations. This is the table 4. So the inter-annotator agreement on relative evaluations. All three annotators agree, 2 of 3 annotators agree, no agreement. Okay. Chameleon versus Gemini, 331, and that's the 31.5%. All 3 annotators agree. It's kind of complicated to like explain the table, but basically the give me a sec. Yeah, basically this table shows how what is the agreement of all the 3 annotators related with the capability of Chameleon versus Gemini in terms of responses. So we have the comparison between Chameleon versus Gemini, Chameleon versus ChatGPT 4, Chameleon versus Gemini, and Chameleon versus GPT-4 Plus. For the relative evaluation, table 4, yeah, this is the table that I was talking about. Table 4 shows the number of cases where all 3 annotators agree, 2 annotators agree, and 3 is not agreement. For each model pair, we have a bit higher than 10% of the cases where there is no agreement among the 3 annotators, considered as a tie in our evaluation, and about 28% to 35% of the pairs, all annotators have unanimous judgments, and in about 55% to 60% of the pairs, one annotator differs from the other 2. This may be interpreted as Chameleon performing similarly to other baselines in many cases, making the relative evaluation challenging. Safety testing 4.4. Safety testing. Weak crowdsource prompts. Weak crowdsources of safety testing. We crowdsource prompts that provoke the model to create unsafe content. We crowdsource prompts that provoke the model to create unsafe content in predefined categories such as self-harm, violence and hate, and criminal planning. These prompts cover both text and mixed model inputs, as well as intents to produce unsafe text, images, or mixed model outputs. We generate the model's response to each prompt and ask annotators to label whether the response is safe or unsafe with respect to each category's definition of safety. An unsure option is also provided for borderline responses. Table 5 shows that an overwhelming majority of Chameleon's responses are considered safe, with only 78%, and that's no, with only 78, and that's the 0.39% unsafe responses for the 7B model, and 19, and that's the 0.095% for the 30B model. And we also evaluate the model's ability to withstand adversarial. We also evaluate the model's ability to withstand adversarial prompting in an interactive session. For that purpose, an internal red team probed the 30B model over 445 prompt response interactions, including multi-turn interactions. Table 5 shows that of those responses, 7, and that's the 1.6%, were considered unsafe, and 20, and that's the 4.5%, were labeled as unsure, while further safety turning using RLAIF has been shown to further harden the model against jailbreaking and intentional malicious attacks. These results demonstrate that our current safety tuning approach provides significant protection for reasonable begin usage of this research artifact. That's good. Let's see what more we have here. We just have like a couple of more pages. So okay, that's what's interesting. We just finished the 4.4 safety testing. And now we are gonna start the 4.5 discussion section. I'm gonna read a little bit of water. 4.5 discussion. Compared to Gemini and GPT-4b, Chameleon is very competitive when handling prompts that expects interleaving mixed modal responses. The images generated by Chameleon are usually relevant to the context, making the documents with interleaving text and images very appealing to users. However, readers should be aware of the limitations of human evaluation. First, the prompts used in the evaluation came from crowdsourcing instead of real users who interact with the model. While we certainly have a diverse set of prompts, the coverage may still be limited given the size of the dataset. Second, partially because our prompts focus on the mixed modal output, certain visual understanding tasks such as OCR or infographics, example, interpreting a given chart or plot, are naturally excluded from our evaluation. Finally, at this moment, the APIs of existing multimodal LLMA machine learning models, yes, LLMS, provide only textual responses, while we strengthen the baselines by augmenting their output with separately generated images. It is still preferred if we can compare Chameleon to other native mixed model models. Table 5, safety testing on 20,000 crowdsourced prompts, and 445 red team interactions provoking the model to produce unsafe content. Okay, basically this table, well, is like this part says safety testing on 20,000 crowdsourced prompts and 445 red team interactions provoking the model to produce unsafe content. Dataset, params, safe, unsafe, unsure. Okay, crowdsourced params, 7 gigabytes, 7 million params, 7 million to 34 billion. Safe, 90% of the cases. Unsafe, 0.4% of the cases. And unsure, 0.4. Red team, well, it's kind of the same, yeah. Okay, this doesn't make too much. Doesn't matter too much. Benchmark evaluations. Given the general capabilities, this is the section 5, by the way. It's like another one. We finished the 4th. Benchmark evaluations. Given the general capabilities of Chameleon, there is not a single model that we can directly evaluate against. Therefore, we evaluate against the best model, the models. Given the general capabilities of Chameleon, there is not a single model that we can directly evaluate against. Therefore, we evaluate against the best models in every category within our capabilities. 5.1 Text. We evaluate the general text-only capabilities of our pre-trained, not SFTD, model against other state-of-the-art text-only large language models. We follow the evaluation protocol outlined by Thorburn et al. 2023. Specifically, we evaluate all models using an in-house evaluation platform on the areas of common sense, reasoning, reading, comprehension, math problems, and word knowledge. We report our results in Table 6. Table 6, comparison of overall performance on collective academic benchmarks against open source foundational models. Evaluated using our framework using API for GSMA 8 key math. We report Mesh 1 unless mentioned otherwise. Okay, this doesn't matter too much. This is like a parenthesis, but basically the table shows the comparison of overall performance and collective academic benchmarks against open source foundational models. Chameleon, Llama 2, Mistral, Gemini Pro, GPT-4, 7B, 34B, 7B, 34B. I think these are the prompts. The 70 million maybe. 7b, 8 multiply 8 times 7b. Mistral, Gemini. Com- Common sense, reasoning, and reading comprehension. Pika. Okay, common sense, reasoning, and reading comprehension. That's good. Yeah, basically this is the table which shows the comprehension of the models and stuff. Yeah. Basically, are the most of them are over 70. Yeah. Math and world knowledge. Yeah, actually, this makes sense completely. Cause this makes sense. Cause usually when I study math and I wanna get some help to solve like a problem, you must to give the AI like a lot of context before to have like a good answer. That happens a lot. Or maybe you must to be pretty precise with the methods that you want to use, because otherwise the model will answer you with a pretty random way to solve the problem. And maybe in your university or where you're studying, or the person who make the exercises for you in the school, they want that you solve those problems in a particular way as they show you. So yeah. Okay, math and word knowledge. It's the most of the cases. It's like under under. It's under 70%. Common sense, reasoning, and reading comprehension. We report zero-shot performance on the following benchmarks that measure common sense, reasoning, and reading comprehension capabilities. P PIQ A. Bisk et al. 2020, SIC A. SAP et al. 2019, Hela Swak, Sellers et al. Sellers et al. 2019, Winogrande, Sakuwachi et al. 2021, Arc Easy, Clark et al. 2018, R Challenge, Clark et al. 2018, OpenBook QI, Mihailov et al. 2018, and Bull Q. We score the problem with each candidate answer and compute accuracy using the candidate with the highest score. All baseline model performances except a few are taken directly from the reported sources. We observe that Chameleon 7b and Chameleon 34b are competitive with the corresponding Llama 2 models, with Chameleon 34b even outperforming Llama 2 70b on fifth, eighth tasks and performing on par with Mixtral 8 times 7b. What the heck? Math and word knowledge. We report 8-shot performance on GCMAK, Koval et al. 2021, grade school math word problems, and 4-shot performance on the math benchmark. We report Bayesian exact match accuracy for both benchmarks by sampling n generations from the model, greedy sampling for n-1, and choosing the answer via majority voting. Despite training for additional modalities, both Chameleon models demonstrate strong math capabilities on GSMA. On GSMAK, Chameleon 7b outperforms the corresponding Llama 2 models with performance comparable to Mistral 7b, 50.9 versus 52.1. Sorry, I don't know what happens when I must to say the numbers lately. Furthermore, Chameleon 34b can outperform Llama 2 70b on Mage and Mixtral 8 times 7b on Mage. Okay, this doesn't make any sense. Similarly on Math Similarly on Math, Chameleon 7b outperforms Llama 2 and matches Mistral 7b, while Chameleon 34b outperforms Llama 2 70b, approaching the performance of Mixtral 8 times 7b on MASH. Okay, and this is the rate 24.7 of the cases versus the 80, again, the 44.7 versus the 48.4. That's the comparison. We also report performance on MMLU, which measures world in domain knowledge and problem-solving abilities using 57 subjects, including elementary mathematics, US history, computer science, and law. Both Chameleon models outperform their Llama 2 counterparts, with Chameleon 34B approaching the performance of Mixed-Modal. A times 7B, Gemini Pro, and the comparison is 65.8 versus the 70.6 division 71.8. Overall, Chameleon outperforms Llama 2 across the board, with performance approaching Mistral 7B, Mistral 8.8 times 7B, Jiang et al. 2023-2024 on some tasks. These gains are likely due to multiply. These gains are likely due to multiple factors. First, these gains are likely due to multiple factors. First, we do 2 epochs over the Llama 2 pre-training data, and in general, use more compute for pre-training. Second, including code data significantly improve performance on text-only reasoning tasks. Lastly, having higher quality data in the last 20% of pre-training significantly improve performance. Image to text, image to text, image to text, image to text. This is the 5.2 image to text. We next evaluate Chameleon on the segment of tasks that requires text generation conditioned on an image, specifically on image captioning and visual question answering tasks, and present results of Chameleon 34B in Table 7. Together with our pre-trained model, we also present results with a model fine-tuned on all tasks together. Chameleon 34B multitask, as well as models exclusively fine-tuned for the specific evaluation tasks. We evaluate against available open source late fusion models, specifically Flamingo, ATB, Alairac et al. 2022, IDEFICS, ATB, Laurengon et al. 2023, and Lava 1.5, Liu et al. 2023, as well as recent closed source models such as Gemini et al. 2023, and GPT-4b, OpenAI 2023. We know that we did not take any special care when formatting the pre-training data to ensure that zero-shot interference can be effectively done. Therefore, we augment the input images or questions with the published prompts used by other models. This was purposely done to maintain the fidelity of the pre-training data. Image captioning. For image captioning evaluation, we report CIDR, Vedantam et al. 2015 scores on the Carpathy test. Okay, again this part. Image captioning. For image captioning evaluations, we report CIDR, Vedantam et al. 2015 scores on the Carpathy test split of MS-CoCO, Lin et al. 2014, and the Carpathy test split of Flickr 30K, Plummer et al. 2015 using Pico Evelacap package. For Chameleon models, we restrict captions to 30 tokens. We evaluated GPT-4b and Gemini models using several prompts and generation lengths via their APIs and report the best performance that we were able to achieve. In the open source pre-trained category, Chameleon 34B two-shot outperforms the larger 80B models of both Flamingo and IDE-FICS on Coco with 32 shots while matching their performance on Flick 30K. With respect to fine-tuned closed source models, both multitask and CFT variants of Chameleon 30B, 34B outperform all other models on Coco, while for Flick Air 30K, the SFT model outperforms other models, with multitask model being a close competitor, 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 with the multitask model being a close competitor. Visual question answering. For visual questioning, visual question answering. For visual question answering, view B. Sorry. For visual. Okay, again this part. Visual questioning answering. For visual question answering (BQA), we report performance on the test deb split of BQA B2 Goya et al. 2017 for BQA B2, the pre-trained Chameleon 34B model with two shots matches the 32-shot performance of the larger Flamingo and IDE-FICS models, while for fine-tone closed models, Chameleon 34B multitask approaches the performance of IDE-FICS ATB is chalked and Gemini Pro, but trails larger models such as Flamingo, ATB, FT, GPT-4B, and Gemini Ultra. Lava 1.5 outperforms Chameleon 34B and BQAB2 potentially owing to its additional fine-tuning on conversations from GPT-4. Share GPT 2023, GQA, and region level PQA datasets, but significantly trails behind on the other tasks. In general, we find Chameleon is fairly competitive on both image captioning and BQA tasks. That's the main point, basically. In general, all this stuff was to say that, in general, we find Chameleon is fairly competitive on both image captioning and BQA tasks. That's all. Good enough. It rivals other models by using much fewer in-context training examples and with smaller model sizes in both pre-trained and fine-tuned model evaluations. Okay, basically we have the whole comparison here in a table, but doesn't matter too much because it's just to give some data that we mentioned before. Well, and that's it. We just need a couple more of sections, just 3 sections more, and are just 2 pages. So we are kind of close, guys. We are gonna finish this. Oh, the video is turning kind of long. Yeah, but doesn't matter though. We're gonna finish it. It doesn't matter. Okay. Related work. Chameleon builds upon the lineage of works exploring token-based approaches for multimodal learning. The idea of using discrete tokens to represent continuous modalities like images was first explored in works like BET Bao et al. 2021, which proposed a self-supervised vision representation learning method based on tokenized image patches. Agash, this is a name, sorry. Agansharyan et al. 2022 extended this idea to learning from mixed-modal documents through interleaved image and text tokens, allowing for joint reasoning over both modalities within a unified architecture. CM3Leon further scaled up this approach to CM3Leon further scale up this approach to autoregressive text-to-image generation, building on the initial building on the initial proposal of token-based image generation in DALL-E. As a fully token-based early fusion model, Chameleon differs from late fusion approaches like Flamingo, which encode images and text separately before combining them at a later stage. Basically, this is the difference between Flamingo and Chameleon. Chameleon basically use tokens, if I understood well. Flamingo makes like a later takes like a later approach to generate the images. Um, what's a later stage? Okay. Other models like Lava, IDE, and Visual GPT also maintain separate image and text encoders. In contrast, Chameleon's unified token space allows. Okay. In contrast, Chameleon's unified token space allows. Okay. In contrast, Chameleon's unified token space allows it to seamlessly reason over and generate interleaved image and text sequences without the need for modality-specific components. This early fusion approach, however, comes with significant challenges in terms of representation, learning, and alignment, and as discussed in Bald through Sites et al. 2018. The most similar model to Chameleon is Gemini. Oh, that's nice. Which also uses an early fusion token based approach. However, a key difference is that Gemini uses separate image decoders, whereas Chameleon is an end-to-end dense model without any routing components. This makes Chameleon a more general purpose model for both multimodal understanding and generation tasks, similar in spirit to the perceiver architecture, which also aims for a unified model across modalities and tasks. In summary, Chameleon builds on a rich history of work in multimodal learning and token-based architectures, while pushing the boundaries in terms of model scale and architecture design by demonstrating strong performance across a wide range of vision language tasks and enabling new capabilities in mixed model reasoning and generation. Chameleon represents a significant step towards realizing the vision of general purpose multimodal foundation models. Okay, we have here finally the conclusion, and then we have the acknowledgements. 7. Conclusions. In this paper, we introduce Chameleon, a new family of early fusion token-based foundation models that set a new bar for multimodal machine learning. By learning a unified representation space over interleaved image and text tokens, Chameleon is a single model that achieves strong performance across a wide range of vision language benchmarks while enabling new mixed model reasoning and generation capabilities. The key to Chameleon's success is its fully token-based architecture, which allows for seamless information integration across modalities. By quantizing images into discrete tokens and training on mixed model data from scratch, Chameleon learns to jointly reason over image and text in a way that is impossible with late fusion architecture or models that maintain separate encoders for each modality. At the same time, Chameleon introduced novel techniques for stable and scalable training of early fusion models, addressing key optimizations and architectural design challenges that have previously limited the scale of such approaches on tasks such as image captioning and visual question answering. Chameleon 34B performs models such as Flamingo and IDE FICS while maintaining competitive performance on text-only benchmarks. Chameleon also unlocks entirely new possibilities for multimodal interaction, as demonstrated by its strong performance on our new benchmark for mixed model open-ended QA. Acknowledgements. We thank Neren Breyer for the invaluable contribution to manually creating safety prompts, which were crucial for our safety tuning efforts. We also thank Pierre Fernandez for his indispensable support with the Chameleon release, Shelly Shainin for her work on the Chameleon image tokenizer, Puxing Su and David for helping us with datasets. Additionally, we thank Mitchell Wartzman for engaging in insightful discussions about stability in large-scale language models, and Mike Lewis for general discussions and advice throughout the project. We thank our Aaron Ratafori, Firal Osganel, Divya Shah, Danny Danny Lifshitz, Danny Lifshitz, Chris, Christian Candon Ferrer, Sagar Hosseini, Ramon Calderer, Joshua Saxe, Daniel Song, and Manish Bath for their help with the safety and red teaming efforts. Okay, that's it. Basically, that's it, guys. Was pretty nice, right? What's a good article? So yeah, I love it. Like, what's interesting, even when I'm not too much into the technical skill with that you need to apply this in real life. I mean, it's like pretty interesting how is the process to build this kind of architectures, and it's pretty interesting. And the vocabulary is like kind of difficult, so these kind of articles are like a good stuff if you want to prepare, for example, like a C1 exam or something, because it has like a lot of vocabulary, kind of complicated words, and you must to try how can I say, to shoot in a pretty good way the cadency of the words in the paper. But yeah, I love it. What I think about this, I think that it's amazing. I am really into this topic. Not into this topic in the sense that I can apply this, but it's pretty interesting for me. And in the future, I would love to switch my field as a developer, software developer, to go through the machine learning stuff and these kind of models. For sure, it's like a long term goal. And nowadays, I just like to enjoy to read these articles and stuff and learn a little bit of that. But that's it, cause I must to I'm in the university and I must to get like a job to make money first and enhance my major and my career and stuff. So that's the thing. I'm pretty focused on that now. I should put more effort on that. And something that happens me a lot. This is more personal. It's being torn like a personal stuff now, but doesn't matter. Like usually, I try to make many things at the same time instead to just be good in one thing. So that's the thing that I must to do. Like I must to be more smart on this. First, I must to get the job, a good position, get experience in the IT field, and then I could decide to switch to another one that is interested for me. But first, I must to grow up and take this serious, because usually I switch between technologies and it's kind of annoying, and I'm not making progress, and it's kind of difficult to handle the organization stuff. So yeah, that's the thing. I wanna get a job, bro. In the things in which I know the most first, and then switch to this field. Well, until now, this video, guys. I hope you enjoyed it. It's almost 50 minutes. That's insane. I just wanted to read it for uh, 30 minutes or maybe 20, but it took a little bit more. Was interesting. I hope you enjoyed, and see you later. And have a good one.